And the other major thing, aside from being able to graph a parabola, is to be able to solve a quadratic, which means you can just focus, if you want to, you can focus in on the quadratic formula. Those are the two major things that you really need to know how to do. If you can do both of those things, you're going to end up with at least a decent grade on this. Now, graphing a parabola involves multiple things. It's not just graphing a parabola. You need to know about the axis of symmetry, how to find the vertex, all that kind of stuff. And with the quadratic formula, it's not necessarily just plugging into the quadratic formula, because you have to get the whole thing equal to 0 first, and that sometimes involves a little bit of algebra, which can affect your ability to identify A, B, and C. So there will be some practice on that. But when it comes down to it, two major skills that you need to be aware of for this test: graphing a parabola and then solving a quadratic. So what we're going to do is we are going to spend a little bit of time going over the big things that you need to know in terms of how to graph a parabola first. And that's why you have graph paper, because we're going to do an example on here. And then we'll go over a detailed example of using the quadratic formula. And those will be the huge things that you're going to need on this piece of paper. And then whatever's left over, you know, if you still have room on the back or on the front, just fill in whatever else you might need for this piece of paper. So we took some notes earlier in this unit about graphing a parabola. And I'm going to go ahead and just bring those up here real quick. And graphing a quadratic equation, here it is. We have 4 steps for this. Find the axis of symmetry, find the vertex, put the vertex in the middle row of the table, fill in a table of values using your calculator, and then plot the points and connect them into a smooth parabola. So we're just going to basically do a copy and paste job into here with an example from our review, and then move on from there. So let's go ahead and just go to the very top of the page, because we want to maximize the amount of space. And we're going to say graphing a quadratic equation. I don't know where the sharpener went. Oh well. So let's go ahead and go with, you know what, I'm going to pick a different one. These are fine, but I'd rather go with something like this. Okay, there we go. We're going to say, here's our example. And our example is going to be y is equal to negative 3x squared minus 18x minus 20. Y equals negative 3x squared minus 18x minus 20. All right, so we're just going to put the steps over here. So step 1. Is to find the axis of symmetry. And that is x equals the opposite of b over, or divided by, 2 times a. So over on the left, we're just going to match this up and call it step 1. So step 1 over on the left. In order to do this, we need to know what A and B are. In fact, it's good to know what A, B, and C are equal to. So what does A equal on this? On this equation, what does A equal to? Negative 3. Remember that the number with x squared is the value of A. And then B, what does B equal? Jaime, help me out here. What does B equal on this one? All right, let's get this written down. Okay. What does B equal? Somebody else. Negative 18. Good. So the number with X is always the value of B. So A is equal to negative 3. B is equal to negative 18. What does C equal? Negative 20. All right. So we've got A, B, and C. Step 1 says to find the axis of symmetry, taking the opposite of the value of B and dividing it by 2 times A. So step 1, we're just going to say X equals, what's it going to look like? What's the opposite of B? 18. Yeah, if B is negative 18, the opposite of B would be positive 18. So that'll be 18 divided by 2 times A is negative 3. All right, so that's going to be 18 divided by negative 6, which equals what? What's 18 divided by negative 6? Negative 3. So the axis of symmetry is X equals negative 3. That's step 1. Okay. Step 2, over here. Says to find the vertex. Now the vertex is the middle point of the graph. And just as a reminder, find the vertex means plug in the axis of symmetry into the equation. Plug in the axis of symmetry into the equation. Substitute. So we're going to substitute the axis of symmetry, negative 3, into the equation that we have up here, negative 3x squared minus 18x minus 20. That's step 2. So over on the left, we're going to write step 2. And so we're going to take our value of negative 3. We're going to plug it in for x in this equation up here. So we're going to say y is equal to negative 3 times negative 3 squared minus 18 times negative 3 minus 20. And then we're going to use our calculator and have it do the work for us. The parentheses here, again, I can't emphasize how important it is to use parentheses when you're multiplying on this calculator. It just makes life a lot easier. You never have to worry about the number coming out any differently than what it should be. So on your calculator, we're going to type in negative 3, and then parentheses, the value of x, which is also negative 3, close the parentheses, and then squared, minus 18, and then parentheses again with the negative 3, and then minus 20. And we get 7. So y equals 7, which means that the vertex is the point negative 3, 7. Because the x value is negative 3 and the y value is 7. All right, step 3. Make a table of values with the vertex in the middle. Step 3, make a table of values with the vertex in the middle. That's what we're going to do next. Ooh. Okay. So that means we just need to create a table of values. And then how many points do we generally put on our table of values? 5, or we could, let's go with 7, just in case. And I'm not sure if this one will work really well for figuring out the zeros of the graph or not. It might not. We'll see how that goes. So we're going to say, so here's step 3. Let's start with 5. Why not? Let's just do 5. X and Y. Table of values, and make it a little bit bigger. 1, 2, 3, 4, 5. Not the prettiest table of values, but it'll work. And the vertex goes in the middle of that. So -3, 7. Right there. And then we put the 2 numbers around it on either side that are bigger than it. So that would be -2 and -1, and then -4 and -5. And remember that whenever you make a parabola or whenever you make a table of values and you list these out like this, the vertex is in the middle, which means that the values of y on either side of the vertex are going to be equal to each other. So whatever we get for -2, whatever the y value is when x is -2 is going to be the same as the y value for when x is -4. And whatever the y value is when x is -1 will be the same y value when x is -5. So we only have to do 2 other calculations on our calculator. And that's it. So remember that as well. You can just use your copy and paste feature instead of typing in the entire thing again. So if you just push up a couple of times, you can highlight the equation that you had. And once you highlight that equation, you can just push enter and that'll copy and paste it. And I'm just going to scroll back and replace the 3 with the 2. So hover over the 3, replace it with 2. Hover over this 3, replace it with 2. So now we have -2 instead of -3. Hit enter and the answer is 4. So that means when x is -2, y is 4. And when x is -4, y is also 4. And we'll do this one more time. But this time, replace the 2 with a 1. So I'm going to copy and paste. 2 gets replaced with a 1. And the answer is -5. So that right there is enough for us to go ahead and graph our parabola. And I don't need you to get up and get a calculator, but maybe have something that you can make a straight line with somehow. If you have a book or a binder, if you need a ruler, I've got plenty up there. Feel free to borrow one. I'm just going to use the edge of this. So we need to go ahead and then step 4. Got to write out step 4. So step 4, which is the last step, is plot the points and connect them into a smooth as possible parabola. Plot the points, connect them into a smooth parabola. That is your goal for step 4. So over here, step 4, we're just going to go ahead and make a graph. And let's just make we'll make an 8x8 graph. How about that? I think that'll be plenty big. So let's see, 1, 2, 3, 4 right here. That'll be the top of it. And then 1, 2, 3, actually 8 by 8 would be more than that, sorry. I have to go down a little bit here. We'll start it over here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's the middle, and then 1, 2, 3, 4, 5, 6, 7, 8. There's the far right side. Just kind of setting things up, and then we're going to draw our y-axis straight down here. So 4, 5, 6, 7, 8. There's the origin right there in the middle. And then 1, 2, 3, 4, 5, 6, 7. There's the bottom. We're just going to make, it's going to be 16 in height and 16 in width, but it'll be going to positive 8 and negative 8 on both the x-axis and the y-axis. And on the test, you won't need to be creating your own graph, but on here we definitely do. So here's our y-axis, here's our x-axis. All right, then we can go ahead and get this thing graphed in just a moment. So go ahead and get it set up, make it positive 8 to negative 8 on both the x and the y-axis. All right, go ahead and get that ready. And then, does anybody remember what is the first thing that we do when we actually put this on the graph? What do we have to do first? I guess it doesn't technically matter since we have our table of values, but does anybody remember what we generally did when we first started graphing these? Yeah, we usually do the axis of symmetry first, right? So the axis of symmetry was that x equals -3. That was the very first thing we did in step 1. And so if we go to -3 on the x-axis, we can do that dotted vertical line just so we can show like, hey, this is the middle of the graph. This is the middle of the parabola. The middle of the grid is not the middle of the parabola. This is. And so I'm just going to identify this real quick and just say, draw an arrow to this right there. And we're just going to say axis of symmetry. That is the axis of symmetry. That vertical dotted line represents the middle of the parabola. All right. Now we can go ahead and put the vertex on here. And we have the vertex in the middle of the graph, and that's the point -3 and 7. So the vertex is always on the axis of symmetry. So from the red dotted line, we're just going to count up 7 spots. So 1, 2, 3, 4, 5, 6, 7. And unfortunately, I'm going to make this arrow go to someplace a little bit different than where I drew it, because that's pointing directly at there. That's the axis of symmetry. I accidentally had it directly at the vertex, which is not what I wanted. This is the vertex right here. I don't want to confuse the vertex with the axis of symmetry. All right, now we can go ahead and graph the rest of the points on here. So the -2, +4 is the next one we're going to put on here. So we'll go to -2 and then up 4, 1, 2, 3, 4 right there. And then we've got -1, -5. So it'll be -1 and then down 5, way down there. And then those 2 points just reflect right across the axis of symmetry. This point is 1 away. So we go 1 to the opposite side, and then we've got that point right there, which is -4, 4. And then this one down here is 2 away, so we go 2 to the opposite side, and that would be -5, -5. And so we have our 5 points on here. And then we're going to do the best we can. Kind of a big graph. We're going to do the best we can to make this as smooth of a curve as possible. about like that. So there's our parabola. That's how we can graph. Now, that's everything we need to know for graphing. Everything right there. If you can follow those steps, you can graph any parabola you need to. The other thing that we did with parabolas, though, is we identified the domain and the range. That's something else that we did on our graphs. And so I do want to talk about that real quick. So the domain, this will just be like let's just make a separate box over here. And say domain. What is the domain for every single parabola? Anybody remember? All real numbers, yes. That will be the answer for every single domain of every single parabola. The range, on the other hand, will, the range, I'm just going to say, I'm going to put a little arrow and say relates to the y value of the vertex. The range relates to the y value of the vertex. What is the y value of our vertex? What's the y coordinate of our vertex on this problem? Ooh. We can actually write that in here too. -3, 7. That is what the vertex is. And the axis of symmetry, we can actually write in x equals -3. A couple more details we can put in there. So for the vertex, what is the y coordinate? This is our vertex. Which one is the y value? 7. So the range relates to the y value of the vertex. It relates to 7. And remember that we have a y, and then we use that number 7, and then we have to decide, are we looking at a greater than or equal to or a less than or equal to on this particular graph? Less than or equal to, yeah. Alicia, can you explain why? Why is that going to be less than or equal to instead of greater than or equal to? Yeah, I mean, the 7, it could be a negative, and the whole thing could be moved down, and that would still be less than or equal to. It has more to do with the direction of the parabola. This parabola is upside down, right? If the parabola was facing up, then it would be greater than or equal to. Every single y value on this graph is below the 7 or equal to it, because the 7 is the top point here. So underneath, so if it's facing down, it'll be less than or equal to. If it faces up like a regular U-shaped parabola, then that would be greater than or equal to. That is a minor detail. This is something that if you don't get it right on the test, yeah, you'll lose a tiny little bit. But being able to graph it is the big part of this. And you should always be able to get to the domain, because the domain is always all real numbers. So if you miss like part of a point for not getting the range right, that's not going to kill your grade on the test. But I still want you to try it, but it's not nearly as important as being able to get the axis of symmetry and the vertex and graphing it correctly and making your parabola look nice. All right, now the other thing that we did with graphs is we solved the x-intercepts with our graphs. We can't solve the x-intercept with this graph because the x-intercepts are right here and right here. They're not all whole number values, which means that we can't use the graph to solve this. Now, there will be some questions on your test where you would. And if it was at a whole number, you could just say like, actually, let's just do a quick estimate here. We're not going to write it down. But this is -1, that's -2. That looks like maybe -1.6-ish, right? Where that line crosses the x-axis, maybe about -1.6. And this one over here, here's -2, -3, -4, maybe like -4.4-ish. We don't really know, because you can't solve it exactly based on this graph. Some of them you can, if it's like a nice, if it went through here, we would say, oh, that's -5. Or if it went through right here, we'd say that's -1 for the x-intercepts. Now, the other way that we can solve this, and this is what we're going to do on the back, is we're going to use this exact same equation up here, the negative 3x squared minus 18x minus 20. We're going to use that same equation and we're going to solve, figure out where the x-intercepts are using the quadratic formula. So flip it on over. Oh, you need more time? Okay, sorry. If you need more time here, feel free to keep working on this. I'll leave that there for a little bit longer and then we'll take a look at the quadratic formula, solving the same thing. All right, we all ready? Okay, flip it over. And on the back, we are going to use the quadratic formula. So and in parentheses, I'm just saying solve any quadratic equation. This method will work for every single quadratic equation. Yes, we know how to do the factoring method, or at least we should know how to do it, but if you forget, just use the quadratic formula. I'm not going to review factoring, solving the factor on this paper. If you want to add that in, if you have more room, you're welcome to do that. But this will be the last thing that we're going to put on here together because the front side of this paper and the quadratic formula, those are the two main things that you need to know how to do. If you can do those things, you will end up with at least a decent score on the test. Okay, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2 times a. So here's our example. It's the same one that we did on the front. So we're going to say negative 3x squared minus 18x equals 20. I'm going to mix it up a little bit. It's the same equation, but I'm mixing it up just a little bit. That looks good. Yeah, we're good. Okay. So step one. Make sure the equation is equal to what? Make sure the equation is equal to 0. Step one, make sure the equation is equal to 0. That equation is not equal to 0. What do we have to do? To get that equal to 0. Subtract 20. Good. Minus 20. Minus 20. 20s cancel out on the right. The 20 does not combine with anything on the left. So we're going to get negative 3x squared minus 18x minus 20 equals 0. Now it looks like the equation on the front. Step two. That's step one. Let's see. So write step one over to the left there as well. Set the equation equal to 0. Step 2, identify A, B, and C. Step 2, identify A, B, and C. Over on the left, step 2. Same as the one on the front. So A equals -3, B equals -18, C equals -20. So same problem as the one that we saw on the front side. Same for A, B, and C. That's step 2. Step 3. Plug into the quadratic formula. So step 3. X equals, here we go. The opposite of B is 18 plus or minus the square root of, remember to use parentheses here, B squared would be -18 in parentheses squared minus 4 times A, which is -3, times C, which is -20, all over 2 times A, which is not -6, that's what's going to end up being 2 times -3. Right there. All right. And then step 4, last step. Use the calculator to solve the addition and subtraction versions. Step 4, use the calculator to solve the addition and subtraction versions. So that's what we got to do. And then you can just write your answers after that. So I want you to plug this into your calculators and tell me what you get for X. There should be 2 answers. Let me know what you end up with. I'll go ahead and plug it in on mine as well, see what we end up with. Cool. Anybody have any answers on this one yet? Do you have any answers? Justin? Yeah, so we could write, the first one I got was, I got negative square root of 21 minus 9 over 3. But we're going to go ahead and swap the order of the numerator and do negative 9 minus the square root of 21 over 3. That's one of them. The other one is x equals square root of 21 minus 9 over 3, which again, swap the numerators and you get negative 9 plus the square root of 21 over 3. And just for being thorough here, this top answer is right around about, I'm going to see if I can fit this in somewhere. This one is about negative 4 points. That's about negative 4.53. If you push the little left right arrow above enter, it'll give you a decimal approximation. This equals about negative 4.53. If you do the same thing with this other one, you get about negative 1.47. Roughly, by getting the decimal approximation. Our answers, though, are these two here. Those are our answers. Now, if you wanted to, you could also write it as x equals negative 9 plus or minus the square root of 21 over 3 and just combine everything together. That's fine. Either way. What I want to do, though, this is the last thing we're going to put on here that you need to have on here. You've got about a half page to put anything else on here that you might want to. I'm going to flip it back over to the front here in just a moment, but go ahead and get this written down. And I want us to go back and look at the parabola that we made a minute ago. And because we said, like, if we were estimating, I think I said it was like somewhere around like 1.6-ish for one of our answers. Well, it wasn't 1.6, it was negative, or not negative 1.6, it was about negative 1.47. So if you go back to the parabola side, where your parabola crosses the x-axis should be right around these two numbers here. Right. Does anybody need more time on this? I am going to be posting this to Google Classroom as well. So, if you want to go back to it this weekend and take a look just to make sure you got everything down, feel free to do that. I'm recording this as well, so I'll post a video to Classroom as well. These are the two major things that you need to know how to do, because if you look through the review here, that's pretty much everything on this review, which means that's pretty much everything on your test. All right, let's flip it back to the front real quick. Go back to the front side. And if we look at where this parabola crosses the x-axis, this one right here, that's about negative 1.47. This one right here, that's about negative 1.53 or negative 4.53. And so we could estimate, I think I said maybe negative 1.6. It wasn't, but it was pretty close though. So your graph, even though it's not exact, does provide a pretty good estimate about where those things should be. And so since we use the same problem on the front and the back, we can kind of connect those two things. Now, Some of the problems on your review and on your test, you will need to solve using the graph. If that's the case, then they will be whole number values if you're solving using a graph. So that's about it. The only other thing that you might want to put on there is the discriminant, which is that b squared minus 4ac, because you'll have some questions like that as well. I'll let you do that on your own. So for the last 15 minutes of class, get started on this review. The first 7 problems are graphs. The final 12 problems are all solving using the quadratic formula or any other method. And then there's 3 questions in the middle that have to do with the discriminant. If you need help on those ones, let me know. And we're going to keep reviewing again on Monday, and then we'll test on Tuesday.